Quickly, who can I make the organizer, co-organizer, so that we have two recordings instead of one. If something happens to my recordings, we have a backup. Yes, quickly. Yogesh, Lokesh, and anybody else? All right, let me make Lokesh co-organizer today. All right. Okay, good. All right. So Ritika, can you hear me now? Is everybody able to hear me clearly? Ritika is not able to hear. Hello? Yes? Yes, everybody is able to hear. Maybe Ritika, one else can hear. Okay, good. Good. So everyone is able to hear. That means there's nothing wrong on my side. So let me address one question. The question is very important and is quite frequent in the life of a developer or a data scientist. The question is, why don't we use R in most of the cases? Why do we need these new tools? The simple answer is that R is slow and insufficient when either the data is very huge or the problem is too complex. Okay? If the data is huge, which can't fit into the memory, into the RAM, then we can't really use R in lots of cases. Even on the competitions like Kaggle, or when the data size is beyond the memory which can't fit in, then the R is not sufficient. The algorithms which are there in machine learning, for example classifications, which we will study in this class during Mahat. So in classifications using R, what is classification? Given a lot of say species, given the details of of species on Earth, create the kind of a tree, create what do you say, inheritance tree. Okay, what does it mean? So if you are given the details of all the species on the Earth and you have to prepare a tree, okay, or let's say you are given the details of all the cars, and you have to prepare a tree such that two siblings are very close to each other, their features are very similar to each other. So in such cases, I mean, the way you compute the features is that every feature you convert it into number and subtract that number, square it and sum it. Okay, so that's how you compare two cars. So you subtract the horsepowers, you subtract the tank size, you subtract the all other features of engine like RPM and max speed, and then you square them and sum it. That is the difference. Sum as in do the addition of all the squares after deducting the features from each other. So that is generally coefficient or distance we call it. So based on the distance we can classify the cars. Now, such algorithms of we call it hierarchical classification. So, such algorithms of hierarchical classification are quite intense. Their complexity goes somewhere from n cube, which is really high, to sometimes n to n, which is actually very complex. All right. Sorry, n into n, sorry, yeah, n. So the best algorithm is somewhere around n cube. And n cube means it's going to take a lot of time, even if these are the very even if the data is small. Okay, therefore sometimes R is slow and insufficient for lots of problems, and that's why most of the movement is either to parallel computing, or distributed computing. Distributed computing. Okay. When I say parallel computing, using many threads and using the GPU, GPU is graphics processing unit. There's a separate mathematical processor that comes in that you can install on the computer. And there's another way, another using the many computers. Okay, which that's what we are learning. So the approaches in both the cases, whether parallel computing and distributed computing, are very similar. In both the cases we try to break down the problem into some form of maps and reduces and then solve it. Most of the time consuming things we divide and then conquer. Okay, so that's why most of the basic functions, whether it's compute creating the tree, whether it's related to computing the distances, and all the algorithms for hierarchical classification, non is the straight bucketing, or there are many algorithms which are a part of machine learning. They are being rewritten so that they are distributed. Okay, even the problems which the one which we discussed earlier, finding the word suggestions, there is a name for that problem. It's called n tuples, or n, there is some word for that, so that also has been rewritten as MapReduce. All right, good. Was I able to answer your question? Was it helpful for others? No. Great. Kulbir, was I able to answer your question? All right. The next question is Spark different from Spark R? So Spark R is a layer over Spark. All right. Is a layer over Spark, and that's we will study Spark, and you will have a clear idea about what Spark is. So the way we have input splits and the data on which our map reduces are running. Similarly, in every data-oriented language, we will study Pig, Hive. We will study. So in Hive, it is database table. Basically, we run code on the data, and we need a form to represent that data. In case of MapReduce, it's input, split, and records. This is what we have in input split. In case of Pig, we will see there is something called dataset, and in Hive we have database table, and in R, or Spark R, we have something called data frame, and in Spark we have something called RDD. So everywhere, the first thing we do is any distributed computing, we break down, we convert our data into records and data sets. Okay, so we try to process each record, or we try to process subsets of the records on many machines parallelly, while end user thinks that they are operating on the whole data set, but internally the system, whether it's Pig, Hive, R, Spark R, or Spark, everywhere system tries to convert that into distributed. Okay, so the user specify how to process a record, and these tools can take that uh, command, or take that program from the user and try to run it on different machine, different threads, and so on. Okay, so these all the layers, whether Pig, Hive, R, Spark R, these are the layers to abstract the user, to separate out, try to hide the gory details of distributed computing from the end user. Okay, and to expose that gory details to the end user, we are trying to go through the map reduce details in this session. Okay, in the further sessions we won't be dealing with internals of internals of the distributed computing. Okay, all right, I hope we are all on the same page. So Spark R is a layer over Spark where a data frame is created over the RDD. Okay, it's not too difficult or too different. It's just that people who are quite comfortable with Spark R, quite comfortable with R, they start using Spark R quickly. A question from you is, what's the difference between data frame and data set? So a data set here we are talking about, we call it data set or relation. Okay. So a data set is something, the same terminology in PIG and data frame is in R. That's the difference. All right. Great set of questions. And yeah. So the world is actually moving towards the whole distributed computing. And because there is no other way, there's no other way for two reasons. One, the CPU is not going to grow further at the same speed. Second, the data read speed is what matters more. All right, so now let's continue our discussion. All right, so yesterday we did not discuss an idea called secondary sorting. So it was something in our generally not that structured. So let this time I've put it into the slides. That's why I took a time. Okay, so what exactly is secondary sorting? The key value pairs which our mapper generates are sorted based on the key. Correct? This we all agree. And the reducer receives the values for each key. Reducer receives groups in which the group header basically reducer receives key and the values. The data is grouped by the key and all the values are received by the reducer function. But unfortunately, by default, there is no order in values. There is no order, there is no specific order in values. So if we have to process or order these values, we have two options. One, if you want to basically, what the objective of the exercise or the secondary sorting is, to order these values. If we try to sort these values inside if we try to sort these values inside our reducer code, then it might overflow the system and it will be inefficient. Remember our problem where I'll go into the details in a minute. So basically, whenever we want to do the values sorting of the values, then we can utilize of this feature of Hadoop called secondary sorting. Okay, okay. Let me do the again the description of flow. The mapper generates key values. Then the sorting of these key values happen, and sorting as in the data gets sorted based on primary and secondary key. Okay, primary and secondary key. Now this is something new for us. And then partitioning happens, then grouping happens, then data goes to reducer. The question is that what all can we control here? What all can we customize? First, you can customize mapper, meaning you can choose what to generate, what not to generate. The key values in itself can be objects, can be complex objects. Both key and the value can be the complex objects. Second, the ordering in which the data should be ordered can be controlled. I will show you how. Not only based on one parameter, but you can do this two parameters, meaning for the same key, same primary key, the secondary sorting will happen on the secondary key. That means when the data gets grouped by the primary key, the values will be ordered based on the secondary key. Okay. Then, once the set ordering has been done, then comes partitioning. Why partitioning? If there are multiple reducers, if there are single reducer, then partitioning does not matter. But if there are multiple reducers, then you want to partition the data such that reducers receives reducer receives the right section of the data. If you partition the data such that same key goes into different reducers, then you will get unpredictable results. Okay, therefore you can control the partitioning by using partitional logic that we described yesterday. Then you can, after the partitioning has happened, then when the all the partitions are received by reducer node, uh, then the grouping would happen, and this grouping again you can control based on the data sorted. You can control on what basis the grouping should happen. Okay, on what basis the grouping should happen. It should happen based on primary and half of the secondary key, or it should only happen based on the primary key. It is completely up to you. But remember, if the partitioning happened such that, so you have to remember that grouping can be done on the data that went into the same partition. If your partitioner logic is flawed, then half of the data you wanted to group together might go into another partition, and hence the grouping will happen in a different fashion. All right, and then after grouping has finished, then the reducer code. So we learned how to control mapper, how to control reducer, and how to control partitioning. But we did not, and we also learned how to control sorting based on the key, primary key, and grouping also we have learned only based on the primary key. Today we are going to discuss what is it, what is the secondary key. Okay, so far everybody is with me. Yes, this is very important. So only Alan is with me. Alan and Lucas. Abru is with me. Good. All right. All right. So good. Good. At least some people are awake. All right. Good. 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 So Ravi, Ashwin, Ashwini, and Prem. Right. So if you have questions, just let me know, and then we can jump into the code. Okay. All right. Next is how do you define sorting? So this sorting, the secondary sorting is something I'm going to go only for Java. You can look at the Hadoop streaming manual that should give you an idea on how to control the secondary sorting. You can basically define the column, and that should be good enough in most of the cases. But if you have to customize that part, you might have to write a Java code. Okay. So, all right. So we are trying to create the secondary sorting by default, which so far we have only ordered the data based on primary key. Now we can, the most important thing which we are talking today is we can separate out the sorting and the grouping logic. The data gets sorted on the mappers and grouped on the reducer. Therefore, the both the logics can be separated out. Okay, so the first and foremost thing is you define an output object, and that output object should extend writable comparable class. Okay, a better thing, instead of talking in air, let me describe the problem. Okay, let me describe the problem. Do you remember the recommendation thing? Do you remember the next word recommendation? In the next word recommendation problem, we were trying to find what we were trying to find a word and then suggestions. Okay, suggestion 1 comma suggestion 2 and so on. This is what we were trying to do. Okay, we were breaking down the values in word, next word, then we can say word 1, next word 1, and then next word 1, then next word 2, and so on. We were breaking down the data like this, right? Everybody is with me on the next word suggestion. Next word suggestion. Okay, so we were breaking down in the next word suggestion problem the sentences into key word 1 and word 2 and so on. Now, the challenge there, we faced two challenges. One, that it was line based instead of sentence based. So with that, we are not going to touch it right now. But the second problem that we faced was that what if there are many values for a key, right? There are many values for a key. For example, there will be the occurrence of word of will be at least 1,000 times. So the words that follow, that words the follow of or the, okay, so the will be like many times, many number of times. There will be many words that follow the. That means there will be many values for the key, the, or of, or any other proposition, because when we are creating key and the next word, key and the next word, and so on. For each word, all the following words are going to be the next word suggestions. So the words that are more frequent will have more number of values because they'll have more number of next words. And effectively, in those cases, our reducer, which gets all the values together, which will try to compute top 5 words by again finding the frequencies of the words, it's going to be in a big soup. So, what to do in these scenarios? Because the reducer will get overloaded. A great scene could have been that the values, these words, are pre-ordered so that when we process the values, we just have to compare the current word with the previous word and make sure that it's a new word, not the earlier word, and accordingly maintain only top 5 most frequent words, right? Okay, because if we could order, if we could sort the values for, let's say, a word called the, all the following words which follow the in the big text, we will get all of them in values together as part of the key value. And in the reducer, we have to find top 5 words out of these sorted words, right? So the problem becomes, if we are able to just sort the data, after we sort the data, after we sort the values for each key, the problem becomes like this: top 5 words from a list of, uh, you can say, top 5 means most frequent 5 words from a list of words which are sorted, from a sorted list of words, from a sorted list of words. Make sense to you? So this problem is comparatively simpler. So in the reducer, all we have to do is go from top to bottom, go from the list from left to right, you can say. I mean, traverse the list. If you encounter a newer word than the previous word, that means that means the new word has started and the previous word has ended. And since we are counting the previous word frequency, we can now check whether is it in top 5 or not. If it's not in top 5, we drop it. If it's better than the even if it is if we can include this in top 5, we can keep it, otherwise we'll drop it, and then we keep on doing it again and again. Okay, so we can use priority queue or min heap of size 5. Okay, so that's those who are not aware about this. Okay, it's actually a data structure, which means we are just keeping the best 5 so far. That's it. Instead of keeping one, like when we find the best in a list, what we do is we maintain top one and then we keep on comparing everyone so far and replacing that. Similarly, if we had to retain two, we we could have just kept two variable x and y and compare the new value with an x as well as y, and we can keep on doing that. Similarly, if we wanted to keep three words, the three most frequent words, so we'll keep these three words along with their frequencies, and then as and when a new word is encountered with the frequency, we compare with the smallest and then keep that one. So priority queue helps in the similar kind of structure. Okay, Liu Song is not able to hear me. Okay, I hope others are. Okay, it's okay. So everybody with me on this so far. So the most important part is, if we could, in our next word recommendation, if we could just find the if we could just sort the values along with the key. Yes, Lokesh, Alan, Ella. All right, now let's jump in. Okay, so all right, okay, good, great. And now let's jump into the problem. So we talked about few things here. One, creating a class called writable comparable that's going to define what's a primary key and what's a secondary key. Then we will create something called writable comparator, on the basis of which we will be grouping the data. Okay, we have to separate out the logic of sorting and grouping. Okay, partitioning also we have to define, otherwise the partitioning also will start happening based on the primary as well as secondary key. Okay, now let's try to define the logic here. But if we have only one reducer, then we don't need to worry about partitioner. Okay, so first of all, you will notice that we defined our mapper like this. All we did was, it's pretty straightforward, it's very cleanly straightforward. Okay, so we cleaned our data, as in we removed non-alphanumeric characters and then splitted the data based on space. And then for each of the word, we are emitting current word and the next word. Okay, and how are we emitting? That's the most important thing. We have created a new data type called two words. So instead of a string, we are emitting this object called two words. Okay, and these two words define primary key and the secondary key. You can see get pk and get sk. These two functions need to be implemented by this class, as well as it has to implement compare to. And what does compare to say? Compare to says first compare based on the first word, and then compare based on the second word. This is called secondary. This part exactly is what we call secondary comparison. Okay, this part exactly is called secondary key comparison. Okay, so compare to is the function which dictates how two couples are going to be compared. First compare the first word, then second word. Okay, that's what the mapper is going to emit. Mapper is going to emit this couple containing first and second word and this value. Okay, although it looks like redundant, but we will see. So this values, the actual one is previous word and current word. So current word is something which we need to emit as well. So this current word is being emitted twice, one as part of emit couple and second as part of this. But here the most important thing is that the data will be grouped by previous word, and data will be sorted by both. Okay, so that's how we define our mapper. That's the only slight change, that we created our own kind of data type for the key, and then in this key contains both the words and dictates how the sorting happens. Now the next thing we need to notice is the grouping comparator. Okay, grouping comparator decides on what basis the data gets grouped. Here it says that only while grouping only compare primary key. Okay, which means grouping has to happen only on the primary key. Now the next step is, so we defined sorting comparator, we define the grouping comparator, and sometimes we might have to define our partitioner, and this partitioner is good enough. It says key, or you can say key dot get primary key, and then hash code, and then divide it by number of tasks. Okay, and whatever is the remainder, that will be the bucket, meaning convert this primary key into a number, that's hash code. Okay, and divide it by total number of reducer tasks, and whatever is the remainder, that will be selected as what do you call that will be selected as a uh, that will be selected as the reducer. Okay, so you can think of this as um, I mean, percentage is done because there could be many ways, but percentage is done because when you divide something by something, the denominator is always between zero and that thing. Okay, D- d- zero and divisor. Therefore, the output of this is always going to be lesser than the number of tasks. Okay, and it's going to be kind of uniform because hash code kind of ensures that. Also, it's not random. Imagine that we put a random word here. We say generate any random number, generate any random number. Instead of this, generate any random number between 0 to number of tasks. What could have happened? It could have been disastrous. Same key could have gone to different reducers, and grouping will result in partial subsets of the values, and that's not what we want. Sometimes it's okay when we don't care on what basis our data is going to be grouped. In those cases it's okay, but in this case we want all the values for a word to be grouped together. Okay, so so we defined first the new data type called two words, which dictates how the data gets sorted. Second, partitioner, and grouping comparator. Once that's done, in the driver, we mention that on what basis we want to do the grouping. This is optional. This is optional. Okay, which is not required because by default the sorting of the actual object is taken. So grouping comparator is what you define here: mapper class, reducer class. Number of tasks, we are defining one. If we are defining two, then we have to define our partitioner class. Okay, and that's it. The output, we are expecting text, and output value is also text, and mapper output is going to be two words and so on. Okay, and rest is our classic case. Okay, so this you can run and check. And one more thing I wanted to show you is this particular piece of logic. What happens, how do actually compare, find out top five words from a sorted list. Okay, from a sorted list. So what do we do here is we go through the values, we go through, keep on going through the values, we keep on, if the previous word was null, that means skip the word and move ahead. If the previous word is equal to the current word, that means we are still having the same word. So we just increase the running count and skip. Otherwise, if the current word is different from what we have, then what do we do is we create a tuple, word count tuple, which the tuple contains this new object contains the word and the running count, and put it into the queue. This queue automatically sorts the data based on the running count, and while adding to the list, we are checking whether if the priority queue size is less than 5, only we just add it, which means first 5 words, unique words, we will just add it like this. And then once it has become first 5, then while adding the data, while adding a new word, we will first check what's the smallest word we are having right now, which is the smallest word we are having, and then we will compare. If the current word is more frequent than the lowest of the top 5, and remove that and keep the current one again, and the same logic applies. The most important thing to understand is in a priority queue, when we peak, it's the smallest number which is at the top always. Okay, so whatever data you put into a priority queue, it gets sorted, and the peak, the top word always is bubbled up, uh, is something which is smallest. So that's how it works. And when we remove, it's the smallest word gets removed. Okay, peak also, this is a very important pattern. Okay, so those who don't understand this part and want to have more discussion, we can have more discussion on this, because when we do the streaming comparisons, we will do the streaming comparisons later on. Streaming as in a humongous data is coming continuously and you have to process that data. In those kind of scenarios, this kind of design pattern is quite frequent. And here you might wonder that this priority queue might take up huge memory. No, it is going to contain only 5 elements. Okay, so this will ensure that even though reducer will get the iterator to millions of values, but reducer will never overflow the memory. Okay, so that was our discussion on the secondary partitioning. So this project has been updated, called SG test, the one which is there in the session number 5. I've created one more folder called next word and updated the project. So you'll get all these projects as well. It was not there earlier. Okay. So, okay. All right. So go through this piece of code. Okay. Go through this next word piece of code, download the project again from session number 5, and you go through this. In case you get stuck, let me know. All right. So all we have done is, one, in the mapper, while giving out, right? While giving out the key value, we have emitted an object called two words. Instead of emitting the object of data type string or text, we are emitting new kind of object which we ourselves created called two words. These knows two words dictates how it should be compared with another object of type two words. Okay, this two word has a method called compare to, which basically this method essentially here in the compare to tells clearly how the object should be compared. It says first compare based on first word. If that is not, that's equals 0, meaning both words are equal, that means compare on the second word. That's all. Okay. So in our all discussions earlier, we were grouping and sorting on the same criteria. But by the use of these techniques, you can separate out the two. Okay, so let this key dictates how the data gets sorted, and grouping comparator dictate how the data gets grouped, and the partitioner dictates how the data get partitioned amongst multiple machines. And let the combiner try to combine the values to the local reduce on every node, and all of these are customizable. All right. Now, this is basically a very simple thing. WC tuple is nothing but a object which contains two things. It's a pair of the word and its frequency. So for each of the word, we have to find top five words, which means all the values that follow a particular word, all the other words, the list of words need to be sorted, need to be sorted all the following words, all the words that follow a particular words, they need to be sorted, and we need to first find out sorted and grouped, and then we need to find out their for each of them we need to find out the who is the most frequent one. Okay, who is the who comes in the top five. Okay, so the criteria, the idea is very very simple. If you look at the reducer, what we are doing here is we basically are assuming that this value is sorted. Okay, so what do we get in the reducer? In the reducer we will get the key, what has been generated by map reducer, and all the values which are sorted inside. Now we will go through the list of values from left to right, and since these values are sorted, so we can simply compare the current value with the previous one, whether and check whether the new value has been started or is still the same. This way we can essentially find out the total number of times a particular word occurs, right, by counting the running count and resetting the running count to 1 every time a new word starts. Correct. So if imagine that uh, the one which we are getting is the apple, the mango, the mango, the okay, and similarly the apple. So when grouping happens, this will get converted into the apple, and then the mango, and then the mango, right? And there might be pair, 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 right? Like this. So this is our key, and these are our values. So these are the words that have followed the, okay? Or you can think of good morning, good evening, 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 and so on, right? Okay. So like that. This is what a reducer will get. This data, please note that this data is sorted. So this is the list of words it has got. Now it's very simple. In the reducer, what you have to do is you start going from left to right and say, okay, we have encountered apple. Okay, and then again apple, so we'll just increase the count, and the moment we notice mango, we'll say that current running count, we will put it aside, and then we'll say our current word which we have noticed is mango. Okay, and then again we go ahead and notice, oh, another mango, we increase the count, then we notice pear. That means we move mango to our top 5 words and start counting pair. Then we notice another pair and another pair, and end of the end of the list. And you can see that when the end of the list happens, then again we are adding to the top 5 words. So this is our top 5 word. Okay. In case there has been more than 5 words, then we'll compare that new word against the list of 5 and check which whether it will remove any of the words from our top 5 or it will be skipped. Okay? Is everybody with me? Ravi? All right. Katie is with me. Yogesh is with me. Good. And great. Lokesh was able to explain. All right. So Ella says that it's theoretically good. I'm happy with that because so try running this and try to understand this piece of code. I know that you're not. I mean, not my everybody is from Java background, but it'll be good. It'll help you to figure out this. Okay, and also this idea here can be further optimized. It has been optimized in the code by using something called min heap or a priority queue data structure. Okay, okay. Even if you have not used data structures much, but sometimes in these kind of scenarios, this kind of data structure comes into use quite often. Okay, and you will see this kind of structure will be coming into use in stream processing. All right, great. So that was our discussion on the secondary sorting. Please look at this next word project in the session number 5 project. Download the project again, configure it again, and you will see the new folders that have been created. Also, take a look at these online resources, these 3 resources which I'm providing here. Along with, there is a book called The Definitive Guide of Hadoop. Okay, of Hadoop, I think Apache Hadoop or something. Okay, so that book is good. So you can try that one. All right. So question is that it is like each key is having one priority key as the value. Not really, not really. So I'll just show you this code again. So here, each reduce code is having a priority queue instance. You see, here we are creating a new priority queue, and when we are passing it here, when we are passing it, it essentially adds this. Basically, there is a function which checks whether to add or skip. Okay, this function could have been anywhere. I just choose to keep it inside wc couple. Okay, but you can keep it anywhere. It doesn't mean that priority key is being passed as an argument to this function. Okay, so priority queue is created. Basically, what is priority queue? It is a top 5 list of so far encountered most frequent word. Okay, it's a list of it's a sorted list of top 5 encountered words so far. That's all. All right. Are we in sync, Ashwin? I think we are in sync. All right. Let's start with our discussion on pig. All right. Don't worry, even if we are a little bit late, that's all right. Okay. Since we have given enough time here, rest of the things will be easier for you. Okay. You will notice that all the concept which we have learned about partitioning, combiner, MapReduce, even yarn and HDFS, all of these concepts are going to be of high value in any product, any product that you learn as part of distributed computing. Okay, even the big and hive, all of those are underneath doing the map reduce. Okay, so should we start with big now? Great, great, brilliant. Okay, so all right, so what exactly is pig? In very simple, I'll keep things very simple. Pig is a way of converting a SQL looking language called Pig Latin. Pig converts Pig Latin into MapReduce underneath, right? So as we saw in most of the cases where we have to just join two data sets, like in the voting problem, just we had to do the joining, and in MapReduce the whole process was complex. Okay, so Piglatin provides you these kind of operators like join, order by, filter, and all of the code which you have done by yourself, Pig will do it for you. Okay, it runs on Hadoop and it makes use of both HDFS and MapReduce. All right. Now, before the way we learn any new language, the way we learn any new language is we look at the code, we again go into concept, we then do some coding, then go back to the concept, and we keep on doing it back and forth. And that's why there's an idea of hello world. Okay, so here let's just show you how the word count looks like in pig. Okay, so if you have to do the same word count of big.txt, we can do it in this way. First, load big.txt where there is only one column called line. We load it in this data set called input. Now remember that this line does not mean that bring all of the data from big.txt and load it into the memory of and call it input. No, it's just an instruction. It's just an instruction to Hadoop. So Hadoop is still taking orders from you and has not gone to the kitchen. You can think, or you can, sorry, not Hadoop, Pig. So Pig has taken order. Okay, so you want to process big.txt. Then next, you say that for each of the words inside this input line, there's a for each concept called for each. For each essentially makes something run on every record. Okay, so for each input generate flatten tokenize. Tokenize means break the input word, break this line on every record. For every record, break the text into words and then flatten it. Flatten it means convert every word into a record, and then you call it this new data set is words. Meaning, what does word have? Words you can think of the way you think of input. You can imagine input like a big database table having only one column called line, and you can conceptualize words in the same way. Words you can think of as a big table that has only one column, and this column contains one word. Okay. Similarly, next thing you do is you do the group words based on the first column, and once the data get grouped, then you iterate over the group and do the counting. Okay, now you see that here is a big difference between SQL and Pig Latin. In SQL, you do all of these things in a very straight single query. There you say select star from a table, or group by column one, group by word, and select these two sentences would look like this. They will look like select word and count star from, let's say, words table, group by word, and that's it. This is what these two statements would look like, right? Now here, these are two separate statements, and once that's done, you print the data. You print the data. All right. So I know that this will be going overhead, but don't worry. Things will be streamlined as we go forward. All right. So now going back to theory, saying, so Pig Latin, as you saw that, it allows how your data flows it from big.txt into input, from input to words, and from words to group to counts, and so on. How you also described how should the data be read from the HDFS, should be processed and stored in multiple outputs in parallel. So here, instead of saying dump, we could have said store. Okay. So before proceeding, do you think it'll be a good idea to run this and test it out if it's working? Okay. So we say data mr word count and input. All right. So let's see if it works or not. Okay. So the way you launch pig is by typing pig command here. This is the easiest way to launch pig. You can also launch it from your home. After logging into this. Next is you take up this file and say, okay, input equals load. Okay, looks like input is a keyword here. Okay, you can say, we can call it lines. That's better. All right, let's just try. So you can see that this finishes very quickly. That means it's not really doing anything. And similarly, here also, it did not do anything much. Okay, it just noted as if, the order is not yet processed. We are adding all these statements. Now we go into every statement, then we have grouped it, and next is that we are going to print the data. Okay. Now you can see very clearly that it is essentially doing the map reduce. You can see that the URL to track the job is here. So we can copy paste it, and again, so it's saying cannot assign requested address. Just wait for a minute. Let's see what happens. Let it, okay. Why it can't assign the, okay. Now it has given us c.cloudxlab.com instead of the internal one. Yeah, you can see that. So here map reduce are being executed and they are successful. Okay. So, and here is the word count. Although the data looks really ugly because the data is not cleaned. Okay. And it says that unacknowledged has occurred only once, and uncomfortable dot has occurred 4 times, and insignificance has occurred 10 times, and so on. All right, so it is able to do the word count, just that the data needs to be cleaned. So question from Ila is, where does this input created, it is physical or stays logical? Right now it's logical, it doesn't get copied anywhere. Okay. All right, so you saw that MapReduce did not provide us joins and etc. Joins are fairly difficult concept in MapReduce, and it takes some amount of work in order to create joins. All right. Now, in case of Pig Latin, the joins filter group by order by the usual stuff which was provided by SQL is available. In case of MapReduce, same optimizations are hard, while Piglatin provides you many optimizations. Okay, just like SQL, Pig can check whether you have provided correct data type or not, because it tries to infer the data type, and you can also control the data types. So error checking and optimization are done by Piglatin, while your code is totally opaque to MapReduce, and you can mess up to whatever level you want in MapReduce, but in Piglatin you can't. Okay. In MapReduce you have many number of lines, while Piglatin is smaller and has does not have to be, you know, most of the script are very small. While you know the Java code, it takes a lot of lines to get things done. The only downside of Piglatin is that it has got limitation. You can only do things which are under the control whatever is provided by Piglatin. In case you want to extend the basic feature set, we will show you how to extend the basic feature set in Java of Piglatin. And in case of MapReduce, you have the full control of processing the data. Okay. So Pig is used in ETL, extract, transform, and load kind of jobs in big data. And for researching on data, iterative, both for iterative and batch processing. So the basic philosophy of Pig is it can handle any kind of data. Pig eats anything. Data could be relational, nested, unstructured, and it can live any it the overall philosophy of Pig is that it would live anywhere, meaning it was designed for parallel or distributed computing, not only for Hadoop but all kinds of systems. Now it's being rewritten as in being implemented for Spark as well. And you'll be amazed to know that the design of Spark is similar to Pig, and both of them come from a basic programming language, the another programming language from uh, Google called Sogel. Okay, so essentially, it's the design of pig Latin is quite generic. The third philosophical pillar of pig is that pigs are domestic animal. They are controllable. They provide custom functions in Java and Python and provide custom load and store methods. Okay, custom load and store methods. Okay, so we'll show you how you can customize the functions in pig, create your own methods in pig. Okay, so pig is designed for performance, and we will show you how pig does the many optimizations and what kind of optimizations are provided by pig. Okay, so pig is basically a client, it's a command, it's not a server. Okay, it doesn't have a database backend, and it's essentially a simple command which takes a, a pig Latin kind of statements and execute them. It doesn't store data, it doesn't run any server. Okay, so you can download pig from pig's release page and extract it and set the Java home, set the Hadoop path and start running. Okay, but in our case we have already installed everything, so don't have to install any of this. You can simply go to your account and type pig. Okay, so question is that it will has to be open jdk. Not really, it can be any, it can be sun jdk or anything, it runs on both. All right, a question from Yogesh: how do we define start and end point of this set of lines in pig? So the moment you say dump or store, the whole program so far created will be executed. That's a very important question, Yogesh. And as we go ahead with Pig, I will show you, and you will understand how does it work. Okay? Unlike our Java program or our SQL program where whatever we do, it gets executed. In case of Pig, that's not the case. It is more like your make file where when you run a command, say make clean, right? When you run a clean command, it will find out what does clean do, and all the things on which clean depends and executes those first and so on. Similarly, when we say dump the data set, it will figure out which data set does this particular data set depends and so on, and do the it'll keep on going up. Okay, we will go into the details, you will understand how. All right, so this is how you install pig. We don't have to install, we can simply ssh to e or d host and type a command called pig, or you can open the same thing in the web console. Okay, you can open the web console and start working on that. That should be good. All right, now the most of the data for this discussion has been uploaded into slash data folder, which is read only and everybody can read data. And in HDFS, you have the permission to manipulate your home folder, so you can store data in your home folder. All right. Now there are a few more things. So is everybody able to launch it? Let me exit here. Okay. So the way you exit, not like this, exit like this. All right. Yeah. Yeah, quit is the command to exit from here. So I've just quit. Now you can click on the web console and then log in. provide the login. Okay, provide password, provide password, and here we are. So after you log in into the console, you type pig and you will have the pig running. Ila's question is, are the pig commands only existing for in a particular session? Yes. So now if I try to say do the same thing, dump dump cnt count, it says cnt doesn't exist, right? And this is something which we created in the previous session and we have exited from that session, right? So CNTD, it doesn't exist in the current session. It says CNTD doesn't exist. So it doesn't store those values of the previous session. Good. So you can log in into Pig using CloudX Lab and start using it. Yes, everybody is able to log in into the console and start it. Okay, good. Now let's move on. Okay, great. Now there are few more things about Pig. One is called local mode. Okay, the way in MapReduce code we had this JUnit test case which was able to run our MapReduce on the desktop, meaning it was running in a pseudo mode of MapReduce. In the same way, we have a pseudo mode called pig-x local. If you don't have Hadoop installed, you can keep using pig-x local. It can be useful for debugging purposes, and without overloading the servers, we can test most of our pig scripts. Okay, so you can install pig-x local. You can try using pig-x local, and any file you try to access in pig-x local, it will be a local file, not HDFS file. Okay, you can see ls command works here and it is showing my local files. Okay, while if I go back, you can press Ctrl D to exit from here. If you execute normal pig, it'll when my ls will give the HDFS directory. See, this is my HDFS folder. Okay, so pig-x local is offline kind of mode and can be used for testing. Now, sometimes instead of interactive mode, if you launch Pig, it launches interactive mode. We call it REPL, meaning read, evaluate, and process loop. REPL. There are many programs which provide REPL in today's time, starting with Shell, the one which we use normally. Uh, Shell commands like the shell prompt keeps on appearing every time we uh, execute a command. Similarly, Python interactive mode. Similarly, in browser you have this interactive debugger, okay, which provides you a console. If you what do you call it, a Firebug. Similarly, Chrome also provides the same thing, and so on. So these are called interactive arguments, and most of the modern programming languages, be it Lisp, be it Java, be it Python, be it Scala, all of these provide you a kind of interactive shell where you can type command and immediately evaluate expression by expression. Similarly, pig also provides one, but in case you want to execute one statement and exit from pig, in that case you can say pig minus e and that command. Okay. And in case you have created a script, what's a pig script? Pig script is nothing but all the statements written in a single file saved into the disk. Okay. It doesn't have to be a specific extension to get executed. It can be any script. Okay. You can execute pig script by saying pig and my script name. So whatever commands which we did here, whatever commands we did in the previous case, okay, let me just show you this. So whatever we did here, okay, we can just copy all of this, put it into a file, say my first pig script. You could say nano, nano, and paste it, control X, done. Also note that all the lines starting with double dashes are comments. Now we can execute my first pig. Did I save it? Yes. So I can say pig my first pig script. Okay. So it's executing my first script. All right. So this way, once the work is done, it will exit, and that's how I can run my scripts remotely on a machine. You can basically do a SSH remote and get it done. Good. So we were able to do the scripting. Okay. All right. And we can also execute only one command in the following manner. Okay. So this is where we are going to spend a lot of time on the grunt. Okay. So by default, when you do not provide any argument, starts an interactive. It starts an interactive console, and that's looks like this. It says grunt here. Okay, it says grunt. Good. Now next is that on this grunt we will be spending a lot of time, and here it provides you all the fs commands, file system commands. So what all does it provide? Let's have a look. We can say ls, okay, and we can also do things like chmod and I mean you can execute copy from local, copy from local my first pig script. It did not execute. Did it execute like this? Yes, it copied from local this my first script. We can check it from cat. You can see that. So we are able to interact very quickly with the file system in pig. These are additional add, add-ons provided to you by pig. Okay, so we were able to quickly do very cool things with the console. Let me take out it into another browser window. So we were able to, print the file from HDFS, see the list, as well as copy the data from local onto the HDFS. So we can use lots of fs commands here. All right, let's take a break for 10 minutes and then back by 9:44 p.m. IST. All right, is everybody back? Let's start now. Okay, so should we start now? Great, great. All right, so this was a brief introduction on how to get started with Pig. The basic construction of Pig Latin, that's the language, is that every step, every processing steps result in new set. Okay, except for dump and store. When we said load, it resulted in input, and mm, and here you can see when these are not processing step. This is I'm showing you my console. Okay, so here you can see that the lines starting with double dashes are the comments. Here, when we said load, it resulted in a data set called lines, and that and then let me check if recording is going on. Good, good. Now, when we said for each, it resulted in words. When we said group, it resulted in grouped. And when we again said for each, it resulted in a data set called CNTD. And then we printed the result. So every processing step results in new set except for dump and store. The UDF functions are case sensitive, as in the functions such as flatten and tokenize are case sensitive, while the while the normal things like load and for each are not case sensitive. Group is not case sensitive. We can see capital GROUP. And the comments, if you have to put multi lines, you can put like C or Java or C++ or C sharp as slash star and up to star slash. And then you have single line comments. All the lines starting with double dash are single line comments. All right. Now, okay. So if you have to find the average value of the New York Stock Exchange called NYSE dividends, and what does NYSE dividend contain? It contains the dividends of New York Stock Exchange. Let's have a look at it. So if we say cat slash data, okay, you can see that the first column contains NYSE, second column contains the ticker name or symbol name, and then the date and the dividend value. Okay, this is the dividend value. Now, if we have to compute the average value so far of a particular each of the symbols, then what we have to do is group by this column and average on this, right? So we have to convert something of like this into this. Okay, so let's get our hands dirty. This is the first script. This is the second script actually. So how would it look like? It look like this. First load the data, then dump. These are optional things. Okay, let's try to do it. We load the data. Here we say divs equals to load data NYSE dividends as name, ticker, date, and value. This is name, this is ticker, this is the date, this is the value. Now here the most important thing to note is the data when we load in Pig, by default, this load command splits the data by tab. Okay, by tab. That means automatically it'll split every record into these four columns. All right, let's take a look. So if we say dump divs, then it will go and get the records from the HDFS. And here again is running the MapReduce launcher. Okay. it would have only mappers, no reducers. Okay, so here it has loaded the records. Prem's question is, we can only load, can't we only load ticker and the value? Can't we only load ticker and the value? You will notice as we go further that it doesn't make much of a difference. Okay, it doesn't make much of a difference because you are processing the data, and when we load, it doesn't mean that we are loading it into the memory. So it doesn't matter whether we give it a name or not. Okay, we can run after this step, we can actually run a projection and skip these columns. But while loading for the first time, we can't skip these columns because anyway the data is going to be, yeah, scanned through. All right. To understand what's going to happen to divs, we can always use explain. And explain tells you how a particular query gets executed in the background. Meaning, when we said dump divs, what all is going to happen in the background will be explained by explain divs. Divs is the dataset name. So when I say explain a dataset name, then it is going to go through all uh, the map reduce conversion process. So it shows you what is the plan, just like in SQL. Okay, so here it is showing you that it only has something called storage. It will look more meaningful when we have more steps and more statements. All right. Next is we are going to group this data using ticker. Okay, and then okay, so it says that the average already exists. So we'll say 9 APR. All right. So it has stored the data in this folder, which we can check from here itself, averaged 9 APR. Okay, so you can see that part 00 has been created inside that folder by pick. Okay, so we can say cat and do this. All right, you can see that we have got the results in this form. All right, so there are a few things you should note. One, that we did not have to explicitly say that this record called VAL is number. Okay, we only had to just say average, and internally it casted it into a number. All right, there are many things which will go into the details. So the data types in case of pig. All right, Ella is facing some problem. I'm also facing the same problem when I'm opening a new console. Try, do you have a putty or something? Looks like the machine is busy. Let me just inform a team. Okay, so I've informed the team. Okay, don't worry, you can try maybe a little while later. Okay, Yogesh's question is, how do we look at the grouping command and how and when to process the grouping exactly? We'll go into the details. Okay, we'll go into the details. And all right, so yeah, uh, a little bit basics about big data types. The data types are of two kinds. One is scalar, which are basic data types such as integer, long, float, double, character array, binary array, and date time. So anything by default is loaded as byte array, meaning as the binary data. And then at later point of time, as the need arises, the data is casted into various things. Or while loading itself, we can explicitly say that this data we are expecting it as integer or long or char array or byte array or float or double or maybe date time. Okay, so you can specify explicitly that a particular column's data type, or you can leave it to pig. Now, there's another data types called complex data types. These complex data types are of type map. So every field or any column can be of map type, whereby it internally every a column could internally store a hash table or a dictionary inside it. Okay, so the map means key value, a collection of key value pairs. The key can be only character array, while value can be further complex type or scalar types. Okay, value can be a string, number, or another map, and so on. The other complex data type is a tuple. Tuple is fixed length ordered collection. Okay. So tuple, let me again explain what does it mean by tuple. While map is a collection of key value pairs, the tuple is ordered array. Tuple is something like an array. Okay. Something like ordered values and like record. A tuple is very much similar to a row in a database table. So you can define a tuple and you can say that this particular field contains further fields in a certain order. Okay. All right. Let me try to open this. All right. Now going back to this. The third data type is bag. A bag is an unordered collection of tuples. Okay, like a database table or data set, it's basically a collection of tuples. Okay, it's a collection of tuples. So here you can see that it's basically a bag of tuples, and where each tuple is having three columns. First column is string, second is integer, and third is a number. It's very similar to a data set of rows and so on. Okay, the thing which differentiate bag from tuple and map is that bag is not necessarily loaded into the memory. It's broken down into tuples, and tuple is something that should fit into the memory. Okay, if the tuple is really big, it will overflow. And therefore, it's very important to understand the difference between a data set and a record. A record is generally smaller, and 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 it should fit into the memory, while the data set is something that doesn't have to fit into the memory and can be divided on multiple machines. Okay, okay. A question from Ila. In tuple, there are three values, but only two values have fields name. Why is it? So it's not mandatory to give the field name. Okay, it's not mandatory to give the field's name, and you can skip the field name anywhere. But which one are you referring when you say there are three values but only two values have fields name? Yeah, here you can see you can refer the fields by position in a tuple, and by default everything which we deal with like divs is a bag. It's the dataset which we talked about so far is essentially a bag. Okay, it's a bag, grouped is a bag, and averaged is a bag, and so on. So a question from Ella is tuple, okay? Now here, so Ella was referring to this particular example. Her question was that there are three values, but only two values have fields name. Not really. It's actually this way. There is a record. It has got four fields. First field is Bob. Okay, it's a string. And second value in this field, in this record or in this tuple is 55. And third value is 12.3. Fourth value is a complex data type called map. So tuple can be made of maps, and maps can be made of tuple, and so on. And that's how complex data structures work. Okay? It's a map containing key value pairs like this. Okay? So essentially, this record contains four fields. Okay? This record contains four fields, and fourth field is a complex data type called map, which has two two key value pairs. Okay, all right, good, very good. Now moving ahead, I hope this explains. Now, Pig is not very particular about defining schemas. Unlike unlike SQL, where we define the data table and their columns, their data types, and so on, here you don't have to. You can simply say load this. Okay, you can simply say up to here, you can simply say dividends equals to load this. By default, it will break down every record by tab and give the name to every column. Or you can go further and specify there to an extent that every data type of every column. Here we are saying exchange colon character array, meaning the first column, please give it the name exchange and its data type is character array. Second is symbol, the column name is symbol and character array. Third is date and character array. And fourth is dividend and float. We could also say here date colon date time. Okay, so what the focus is that either you can specify just no data type at all, or you could go to any limit you want. Okay, and pig will take care of both the scenarios very well. Okay, if you do not specify the data type, it will try to guess and then cast the data whenever required. It will do the cast whenever required. Now in case you have got complex data type in the physical storage, you can, while loading, you can either simply say a, say we are saying load from my complex data type as a, or we could say a colon map, my field name is a and the data type is map. Here we could say map square if the data is a map. Okay, and physically it will think that the data would be stored in this format. All right, then it could say a colon map and then the data types. So while defining a field, while loading a data and defining a field as map, we could just say it's a map, or we could go to a limit saying it's a map containing the value which is of the data type tuple. Okay, so since in map the only thing you have to define further is the data type of the value, because key is string. Okay, so you could go one level up and one level into more details. It's up to you how the more clarity you put in here, the more optimization you will get. Okay, similarly, while defining that a data type is tuple, you could either say simply tuple or say tuple and give the column names, or you could go into further details and specify the data type of each of the column names. Similarly, in case of a bag, you could define what what kind of tuples does this bag contain, because bag's data type is only the data type of tuple, because bag is a collection of tuples. Therefore, you only have to define the data type of tuples. All right. And whenever you need to cast or convert the data type of one data into another, you can explicitly say that convert this float into integer. Most of the cases, pig will try to convert by itself, but in certain cases, if you want to convert something explicitly, you can do that. All right. Now the first command, Eli's question is, it's a very good question actually. Let me explain this. Okay, question is, what does this compare to MR? We didn't consider this type of data as in NYSE dividends there, right? So it's kind of the idea of data types is inherited from SQL data sets, because so in case of MapReduce, the idea of data types is not there. The only data type we had to define is what will our mapper give out and what will our reducer give out and so on, right? That ensured that mapper and reducers are giving out and taking the same, I mean, whatever mapper is giving out, reducer is taking the same data type, right? So there was no such idea of data type of the data we are loading in. Okay, this is something specific to pig, and the idea comes from SQLs, because if you have data type clarities, it makes a lot of difference in the data processing. All right. So inside mapper or reducer, these translations will happen, and because of these kind of fields and data types, we are able to do joins, grouping, and other things. All right. Now, so you can see that we can either say divs equals to load. We could simply load the data, and this will load the data, guessing the data types. By default, everything will be byte array. And later on, whenever it's needed, it will convert the data into that particular type. By default, the by default, Pig thinks that the data is separated by tab. But if you want to separate the data by using comma, then you can use a system like this. Okay, so it will assume that the data is splitted by comma. Now, even though it splits the data by comma, it does not defend against the situations like CSV files where comma is inside the field. For that, you have to use CSV parser. I'll detail that out. So we can use various kinds of storages to load the data. Whether by default, Pig provides a storage called Pig storage. You can load the data from HBase by using HBase store. You could load the data from JSON loader, and so on. You could load the data from XML using Pig. Okay. Also, it's completely okay with Pig that you specify asterisk in the file name, and it considers that as a wildcard. Okay, it will expect these files to be in the HDFS, not in the local file system. If you are trying to load JSON, you have to say load the file name using JSON loader, and then you have to specify the fields that you want to pick from this JSON. Okay, by default, it will assume that this JSON is made up of arrays. Okay, made up of arrays, array of objects where every record where the JSON object contains food, person, and amount in the object. Okay. What about a question from Ella? What about data that is semicolon separated or with one space between? You could say using storage and semicolon here or space. Okay, good. Now, so this was the pig load structure. Now, if you are trying to figure out what's wrong with your pig query, okay, you could use explain as explained earlier, and you could use describe dataset to just see the schema of a particular dataset. Okay, it will show you the schema, and in case you are going to develop a lot of pig script, you could use syntax highlighting tool. There are pig eclipse plugin, similarly vim, emac, and for Macintosh, there is a TextMate editor. So it has a syntax highlighting tool for all of those. All right. So the loaded the data from HDFS. into a data set. It did not really load, it just made a note of it that when the data set get executed or relation get executed, it has to load the data from there. Okay. Inverse of load is store or dump. Okay. Stores a data set into a file, and this file will be by default in the HDFS, but you can change the behavior by using various kinds of storages. If you want to store this data set in HBase, you could say using HBase storage, and then it will store in HBase. Okay. If you want to store the data using comma separated instead of tab, then you could say using pig storage, comma. Okay. It will save this data as comma separated. The dump command prints the value on the screen, and it's equivalent to saying print. It's not too useful, but it's useful for debugging. And sometimes if you are running a script and you want to save the data by redirection, in that case you would like your script to print the data to standard output. In those cases, dump is useful. All right, so that was our dump command. Next is for each. For each, the first processing step, which we are talking in pig. So in for each, what it does is it is essentially internally translate into map. Okay, so it basically executes a logic against every record in the data. Here basically it's going over, when we say for each data set and say generate a column and value, it means go over every record of divs and generate these two columns. Okay, those who are coming from SQL background, they will say that it's equivalent of saying select A comma B from my table. Yes, it's a projection. It's a projection, and it helps you do certain projection from all the records in the whole data set. Okay, so this for each statement is for mostly the projection. So when we store the values, it will only consider, or when we process this data set, it will only consider these two columns called ticker and the value. Yes. Ila's question is very good. Yes. Ila's question is that load and dump and store. So difference between load, dump, and store is former are logical and later is for creating physical object. Yes. So store creates a physical object, while load means creating a kind of logical structure saying this data set means that file. Whenever somebody interacts or reads this data set, it will it will read from there. Ila's question is, can we give a file path in the for each statement? We can't. We have to specify a data set's name. The way we are saying for each this, then this. Okay. So unlike SQL, where we tend to do everything in a single step, in Pig, we want to break down every big query into small step. Okay, we tend to break down, and that's the main difference between Pig and SQL. Okay, all right. Next example of for each is that we could load the data in this form. Okay, saying price equals to load and these columns, and then we could do the projection in the following manner. We could say for each data set, which is prices, and generate close minus open. It will do the mathematical operation of subtracting close and open. Okay, in case you had loaded the data like this, there was no this part, then also you can do the for each by calling the columns with their position references. Okay, so we could say $6 minus $3, meaning 0, 1, 2, 3, 4, 5, 6. This is $6, and this is 0, 1, 2, 3. This is $3. Okay, a question from Kulbir is, can we use Pig to load from dynamic files? As in, I did not get the dynamic files, the files which are continuously changing. So if a file is continuously changing and you are saying dump x, every time you type dump x, the whole process of MapReduce will happen, and you'll get a new result. Okay. So yes, we can use Pig to load from dynamic files. We can pass the file name as argument. So further addition is, the definition of dynamic file was the different name but same structure. So you can pass the file name as argument. Question from Eli is, can Pig connect to relational databases like Oracle, Sybase, and then data can then be joined with unstructured data? So, all right, it's a difficult question to answer. So, I'm not sure if they have provided a connector to talk to Oracle and Sybase. Okay, but there would be some connector. I would have to take a look at it. Okay, the general way of doing this kind of work, the general way of doing this kind of work is copy the data to the MapReduce. Remember that any command you execute in Pig would result in MapReduce. Okay, so if there are two tables, one in HDFS and other is in SQL, it's going to impact SQL really, really bad, because every record has to be joined against a data lying on a remote server. And the joining, the way it happens is that we take a record in the map and then take a record from the other file and then try to join. So definitely this is going to be very difficult, but I'm not sure if they have implemented. But from my hypothesis, it's going to be very difficult. So I'll have to take a look at if they have implemented or not. Good question, Kulbir. Yeah. Now coming back to Ashwin's question. When the velocity of data is too high, is it feasible to use Pig? So batch wise, yes, okay, but not continuously. Okay, so whenever we have this velocity of data too high, we need to process the data as and when it comes. The flow is, the general way is, batch wise means, okay, batch wise means we or a scheduler execute certain task. Okay, In case of a data high velocity, the data pushes, data causes the execution. You can say that your processor, your any computing element will keep on waiting unless there is a data, and as soon as new data arises, it executes. Okay, so essentially your program keeps running indefinitely. Okay, and pig does not support that. Pig by default is batch wise. A question from Ashwin. In MapR, also we need to follow the same process? Yes. So MapR also is batch wise, so it's not good for high velocity data. Okay. A question from Prem. In the local mode also data is loaded from HDFS? Answer is no. You guessed right. A question from Ila. Or we could load the data from RDBMS to HBase and then join the file. Yes, that's possible. You could copy the data to Hive slash HDFS CSV file or some other format and then join. Okay, for this you could use Scoop. Kulbir's question is, do we use Uzi to schedule peak jobs? Yes. Good, great questions. All right. Now, sometimes we have to select the columns like a wildcard character. So we could say dot dot. That means up to that particular column. So we could say all the columns up to open, or we could say open dot dot close. That means give me only the columns starting from open till close. Okay. Or all the columns starting from volume is what I want. Then I can say volume dot dot. Okay, so next is Ashwin, which is the best way to handle high velocity data continuously. So you could go with Storm or Spark, and there are a few more tools. All right. Now, good. So now let's see if you understand what's going to be beneath the skin, and try to think every time that when we are doing something in pig, it's converting into MapReduce. It's like pig being your agent of converting the kind of query, SQL query, into the MapReduce. So these are very similar to SQL queries, right? Piglatin is very similar to SQL, just that it's far more simpler than SQL. And so question to all of you is, will this have any reducer side code generated? Okay, will there be any reducer when we say for each prices generate close minus open? Anyone? Will it have only mapper code, or will there be reducer as well? Yes, only mapper. Great, great, great. So it'll have only mapper side code generated. There was one question from Ravi. So if pig can't be used for near real-time processing, are there any tools available? We'll talk about Spark streaming, and there are tools like Storm for real-time processing. Okay, next question to everyone. Sorry, it's not a question, it's just a break time. All right, so going ahead with this. All right, further more details about for each. What happens in case of a complex data structure, such as there is a folder called pig, under that there is a file called baseball. Let's take a look at it so that we can objectively understand what exactly pig is going to do. Okay, so let me go into file browser. In case the file browser is not working for you, you can just say slash file browser. Okay, and go to the top folder into the data folder, and then you could say pig. All right, so we have baseball data. Now this data is very important. The fields are separated by tab, and the complex data is saved in the format that we explained. A hash a bag is stored in the form of curly brackets. You can see that this is a bag. A map is stored as square brackets. Okay, so let's say we have to churn this kind of data. Let's say we have to churn this kind of data in pig. So we can simply say that this is a string, and this is a bag, and this is a map. That's all we can say while loading the data. Okay, let's take a look. So we are saying name is a character array, which means a string, team is a character array, and traits is a bag, while bat is a map. Okay, so let's try to load this data, and there we go. We are saying data pig baseball, so it has loaded, and we can now say describe b ball. These are the baseball records. So you can see that it's essentially showing whatever we have described in the ads. Okay, it's very important to keep an eye on this. All right, so we can say here, next step, we can do things like, let's say we want to pick only let's say we want to pick only the batting average. Okay, we want to pick only the batting average, and what does that mean? It means that this particular value we are looking for this particular value. Okay, we are only looking for this particular value. All right, so what do we do in this case? So we can dereference a particular map using hash, and this is how we go about it. So we'll say for each b ball generate name. Okay, that's name. Okay, and bat is this fourth column, the last column, and under that just give me a particular value called batting average. So this is how you can deal with a complex data type as map. Okay, so you could say dump avg. Okay, quick question. This particular pig Latin script with these two statements, will it have any reducer? So, do you think any aggregation or any kind of thing is happening? So, it's not calculating average, it's basically picking it from the hash. It's just picking up from the fourth column and showing it. So, Ashwin and Lokesh, it's not computing the average, it's basically picking from this map called bat, this particular column here, the last one, that's it. It's not computing anything. All right. So if you had to write a Java code, you would not have a reducer. You will just go with every line, break it down by such and such, and then pick up this field and dump it to the output. Right? You'll get one line at a time. You will break it down by first tab, then you will break it down by commas, and then pick up this value and display it to the output. Right? That's what you will do. So you can see that that particular code has actually neatly picked up our value. So we did not have to write much of a parsing logic, and it has done a great, wonderful job of picking up the values. Okay, so this particular piece of code is showing the projection over complex data types. Okay, similarly, if you have to pick up a particular column from tuple, you can simply say go over the dataset, generate tuple dot first column or tuple dot $0 if you don't know the column name. And similarly, if you have to do the bag projection over bag as in iteration and picking up a particular data from a bag, you can simply do something like generate b.x. Okay, meaning every record of this bag will be turned into a single record. Similarly, if there is a bag containing three columns, we could have two columns, and instead of saying b.x comma b.y, we could say b.x comma y. All right. So the other examples of for each could be these, where we are trying to do a complex calculation as part of the select statement or for each statement. Okay, so we are saying for each data set, generate dividend into 100, and we are giving a column name. Okay, so the output which we had in the previous one, let me just go back here. So here, what would be the name of the second column? That's the question. What would be the name? The first one is clear, it will be the name. What will be the name of the second column? Let's check by saying describe average. Describe, describe average. It says the first column has got a name called, and data type of first column is character array, while second column doesn't have a name and its data type is byte array. You can see that. Therefore, we could also say here, that's optional, we could say batting AVG. Okay, in that case, it will get a column name. All right. Similar. So here, this is what we are trying to do. After multiplying something, we are saying that the name is this, or we could say. So, so essentially, for each is equivalent of select. There are many functions that you can execute as part of for each. The way we are executing asterisk, we could execute multiplications, square root, or if you're using uh, string functions you can execute. So there are many functions which are available as part of the projection. We could execute mathematical functions, or we could execute string functions. We could say, let's say you want to split certain data, then you could use regex extract. Okay, what does it mean? When we execute regex, so the tagged expressions like this, okay, meaning first expression colon second expression will match against the string, the data, and then it will pick up the index which you want. A easier one is regex extract all, meaning it will take the record and then it will take basically the column name, whatever you pass here, the column name. It will take the value of that column, that field, and then match against the regular expression you pass. And for every tagged expression, it will create a column. Okay, for every tagged expression, it will create a column. Tagged expression or groups. Okay, so that's what a reg extract is. Make sense to you? So similarly, there are many functions which Pig provides to you, like datetime functions, get year, get date, convert a text into a date object, and so on. So there are many more functions which you can use. All right. In the using, when we are loading the data, we used JSON loader and we used pig storage. Similarly, we used HBase storage. If there are other formats of the data, such as Avro, such as binary, and if there are if the data is compressed, then you can use these. Mostly the compression is automatically handled by pig internally. Okay, so coming back to what we're talking about, so there are many built-in function lists which you can execute as. Okay, we could have many function lists. Now there are two questions from Ila. One is, some fields don't have batting average, can we filter? Yes, that's what. There is a filter command in pig. That's what that filter command is for. And next question from Ila is, why do we have second dividend into 100 statement? It just shows that you could have another column doing the same thing without a column name. Okay. All right. Now moving on to little more complex operations. The first such complex operation is group by. What does group by do? Group by groups the data by a particular column. It doesn't do any aggregation, it just groups. Okay, it just groups. So what happens in this case is, when I say, let's say there is a data set in this form where first field is a string and second field is a float. Okay, and then we want to group this data by age. This is our big command. It says b equals group a by age. Okay, so if our a is this, b will be this, and the schema of a was, it has name, age, and gpa. Name was character array, age was integer, and gpa was float. Okay, so when we group a by age, which is 18, right, which is 18, It's a little confusing, so let me put some spaces. Okay. So when we group the data by 18, so John and Bill will come together. The full records will be combined together, and the data type of this second column is map. It is not map, it becomes a bag of tuples. Okay, so this whole bag of tuples will become the field. You see that? So second column is a bag of tuples which belong to the same age. Is this data structure and the schema clear to everyone? It's very important to understand the data structure. Okay. Second, next is you can group by multiple columns. Okay. In those cases, those two columns will make a single field. Okay. You could group A by two columns. Then the first field is going to be a tuple containing those two fields on which you are grouping. Make sense to you? Alright. So that was the grouping. Just opposite of grouping is flatten. Flatten means ungroup my data. So if I have a data of this form, okay, if I have a data of this form, meaning Sandeep knows C and C++, Arun knows Shell and C, and Mani knows Java and C++ and Lisp. Now, if we had to do that, who are the people who know C, bring them together, who know Lisp, bring them together, and so on. So, what we have to do is first ungroup it based on the programming language and then group it based on the programming language. So, this is what we're going to do is we are going to load this data in this case. So when we load this data, it creates a data set called X, and then we are saying for each X, generate, name, and flatten. Okay, what is flatten do? Flatten converts every record into many records such that whatever language you have flattened in, it becomes like this. Okay, so Sandeep C plus, the single record got broken down into two records. Okay, this whole thing you can do it in the map phase itself. Again, there is no need of a reduce phase. Okay, so we can say dump p. Make sense to you? All right. So that was flatten. Flatten is just opposite of group. All right. So there was a question from Ella saying, can we remove certain record? Yes, we can using a separate command called filter. So you can say filter dataset by, then there'll be a condition. The condition has operator and operands, and condition can be combined with another condition using logical and or and others. A condition could have operators which are string based, and the operator could be mathematical operators saying greater than, less than, or it could be string operators such as matches a regular expression, or it could be date time operator, and then they can be combined using and, or, and then brackets. Okay, so what does this command do? Anybody? When we say let's just load this, okay, we have loaded divs. Good. Now we are saying, what does What would this particular dataset contain? Yes? What would be the result of it? Anybody? When we say symbol matches CM dot star, what does it mean? Yes. All the strings, it will only filter, the filter will only keep the records where symbol name is CM dot star. Yes. So Kulbir is saying that this is equivalent of this. Select star from my table where symbol like this. 0 or more, this means 0 or more of dot. Okay, asterisk means 0 or more of the previous character, and previous character is dot, which means any character, meaning cm, after cm there could be anything or nothing at all. Ila's question is null evaluates as double quotes? That's for empty string. Double as two single quote means blank string. Okay, we could also say reverse of this condition by putting not before that, and we could also combine multiple operations by and or like this. Okay, you can see more operations here. You have arithmetic operators, plus, minus, grade, and you have logical Boolean operators. Where are those Boolean operators? And or in that. Okay, so there is a conversion table here. You can take a look at it. That a bag can convert to a bag, while bag can't convert to a tuple, and so on. Okay. All right. Similarly, there are many more operators you can go through. All right. Now, question is again, I'm keeping everyone to the fact that there is a map reduce going on under the hood. Will there be any reducer generated for this particular code? Anybody? If you had to do the same thing, filter divs by symbol matching this, where divs equals to load such and such file. So question is, does it generate any reducer or it's only the map? So let's take a look at it. Did it generate any mapper, reducer, or were there any reducers? So we could go into the details saying explain. Okay, so it says that first divs will get loaded, the data will casted into character, array, and so on, and then after loading, okay, after loading, this casting and translation will happen, and then once that happened, then we will have matches and the filter that would happen, and that's it, and then store. Okay, so that's the map reduce plan. Okay, all right, so you can see that All right, I'll just show you some more things. So here, if you go into this particular page, it'll show you what happened here. Just again, change this internal name into c.cloudxlab.com. And here there are no reduces. You can see there are total 0 reduces. There is only one mapper. Okay, good. Question from Ila is that I'm guessing that we could also use filter expressions such as high minus low greater than 2. Yes. Okay. But I think the right approach in the cases of pig is that you project it first as diff and then compare diff against true. All right. So yes, everybody is on the same page. All right. The next statement is order by. Okay. So you can order by multiple columns and multiple fields. You can order by the data based on multiple columns and the fields. Also note that you can also specify whether ascending or descending based on in your order by, and that should be good. All right. So your question might be then, how did we do this ascending descending in case of MapReduce code? Okay, so while we defined our two values in the last example which we gave you, there was a compare to. Okay, if you want to do the inverse, you just subtract a minus b instead of b minus a. Okay, take a look at the project and then you will get an idea. All right, next is that the distinct. If you have to find distinct set of records from a data set, you could simply say for each, distinct data set, and that's it. It'll give you distinct records from a set of records. Okay, so distinct is basically for the complete records, and you can use distinct. So quick question to all of you. This particular will distinct generate any reducer side code? Anyone? Distinct. Distinct basically finds distinct records. Okay? Records, complete records. So do you think to find distinct records, do you need sorting? Do you need to use reducer side code? Okay. So let's say in the dividend example, we have to find the distinct name of symbols. So question is, will it use the will it have the reducer side code or not? Okay, let me load it again. I have killed it. I've just copy pasted that code where we are first we are loading data from here, and then we are saying project only the symbol, pick up only the symbol column, and then find out the distinct of symbols. Okay, so the question is, does it have does it have a reduce phase? Let's take a look. Okay, let's take a look. And where did it go? All right, do you see the URL anywhere? Okay, the timeline service is here, and the job. Okay, here is my URL to track the job. Again, change it to c.cloudxlab.com. I need to find out how can I change it from internal to the public. Now you can see that there is a reduce phase. Do you see that? There is a reduce phase. All right, great. All right. So even if there are no, there is only single mapper, then also there will be a reducer in this case. Why? Because Hadoop needs to sort data for you. Okay. Most of the work of sorting the data is handed over to Hadoop by Pig or by any MapReduce job, and sorting happens only if there are reducers. Otherwise, there are no sorting. Okay. So everyone with me on this? Alan and Ron. Great, great. Kulbir, Abru, Prem. Make sense to you? All right. Now comes the time of joins. So we'll discuss the joins in the next session. It's very straightforward. Join one data set against another based on a column or based on multiple columns, and we can join the data sets. All right. So we can join the data set, and we will go into the different kind of join, left join, right join, unions, and more things into Pig in the next session. Okay. For now, you can start attempting the quiz and the subjective questions. Okay. For most of the part, you should be able to attempt the subjective questions. Just that the join part is something which we have not touched today. We will go into the details next time. Okay. So you have joins, left join, and right join. We'll go into those details next time. All right. So thank you very much, and we'll continue our discussion from 42 slide in the next session. Bye bye. Have a great day. All right. Thank you, Abru. You too have a great week ahead. Feel free to drop a question